everybody, welcome to the lesson on measures of spread. So previously we had looked at measures of center, the mean, median, mode that we talked about, and that's one of the things we like to know about a data set is where is the middle. Another thing we like to know is how spread out is it from that middle? Are all of the data points clustered right together, or are they spread out really far? And that's what we're going to look at in this lesson. And we could look at these for either the sample or the population. We're going to focus mainly on the sample, but keep in mind that we're always using the sample to estimate the population. Now, another term for spread is variability, and I'll use those two terms interchangeably. So in this lesson, we're going to focus on two measures of spread. One is the range, and then the other one is the standard deviation. So if we start with the range is calculated as the maximum data point minus the minimum data point. So in this first example, our minimum data point is 20. Our maximum data point is 100. So the difference there is 100 minus 20 gives us a range of 80. Now, it's not incorrect to say that the data ranges from 20 to 100. However, when they ask for the range, they're asking for that difference, which is 80. If we look at the second data set, our maximum data point is 74, and our minimum data point is 67. So when we do our maximum minus our minimum, we get 7. So we've got two data sets there. The range is smaller on the second data set, so that one has less spread or less variability than the data set in example 1. All right, so that's all there is on the range. Standard deviation is a big one for us, though. Standard deviation, we're going to use it for the whole rest of the semester, just about. And if you're looking for a common sense interpretation of standard deviation, it's reasonable to say that it is the distance of a typical observation from the middle. If you're thinking about it like it's the mean of the distances of the observations from the mean, that's pretty close. It's not exactly that, but if you think about it as how far away a typical observation is from the middle, that's a good interpretation. Just like when we were looking at the sample mean and the population mean, and they had different notation, we had x bar being the sample mean and mu being the population mean. With the standard deviation, we've got the sample standard deviation, which is just an S. It can be lowercase or uppercase. I've seen it both ways. And for the population standard deviation, we use this lowercase Greek letter sigma. I know you've seen the uppercase sigma, but this is lowercase. It looks like an O, but it's pretty close to an O, but they call it sigma. So sigma is our population standard deviation, and we're going to use S, the sample standard deviation, to estimate the population standard deviation. And so, as you remember, because S is based on a sample, it's a statistic, and because sigma is based on the population, it's a parameter. You may, if you're looking at an academic journal article, you may occasionally see SD used for the standard deviation, but that's not really the mathematical notation for it. So that's what we're going to use is S and sigma. So here's a formula for the sample standard deviation. And it looks like a lot, but here's what it's doing. If we start from the inside, we take every observation, that's what x is, and we subtract the sample mean from each one of those, which means we have to first find the sample mean before we can calculate the standard deviation. So we're going to take every observation, subtract the mean from it, and square the result. And then we're going to take all of those, add them up, divide by the sample size minus 1, and then take the square root of the whole thing. Let's do an example. So here's the example we were looking at a minute ago. And this is the second data set. It's actually not the data set that's showing up here. It's the one that's down here. So 74, 70, 69, 67, and 70. So we first have to find the mean here. The mean of those observations is 70. So we're going to take each one of these, subtract 70 from it, and square the results. So 74 minus 70, which is 4, square that, we get 16. All right, and we do that all the way down. Be careful on these ones that are negative. Make sure you square the whole thing. Don't just do one squared and then take the negative. So all of these should be positive. All right, so here we've done every x minus the sample mean squared, and now we're going to add them up. So when we add them up, we get 26. That's going to be the top part of that fraction. Okay, so that's what's up here. So now we have to divide by n minus 1. N is the sample size. So it means, so in this case, we've got 5 observations in our data set. 5 minus 1 is 4. So that means 4 is what goes in this denominator. So we're going to do 26 divided by 4, which should give us 6.5. And then we take the square root and we get 2.5495. And I'll show you on the calculator. If we do 26 divided by 4, you see that gives us 6.5. And then I'm going to take the square root, and that gives us 2.5495. So this is telling us that in our data set, the typical observation is about this far away from the mean. Now, there's more than one way to write this formula. Using algebraic manipulation, some people have written it in a different way. And your book calls it the shortcut formula. The shortcut really isn't any easier. And it may show you how to use the shortcut in my stat lab. So be aware that if you're looking at help me solve this, they may show you using that formula. And if you want to do that in my stat lab, that's fine. But if I ask you to do the problem to calculate the standard deviation by hand, I'm going to be asking you to use this formula. The reason is that, and I don't ask you to do a lot of hand calculations in this course. The ones that I do, it's because I think that it'll help your understanding to do it by hand. I distinctly remember when I was learning standard deviation, once I did the formula a few times, I sort of got what it was telling me. If you think about, and this is suspending order of operations for just a minute, but if you think about, you're squaring this and you're also taking the square root. So those, not really, but in a way it's almost like they cancel each other out. And then what you've got left is these distances divided by almost the number that there are. So this is where that interpretation is coming from, that it's it's almost like the mean distance. Okay, it's not, because we can't just suspend order of operations, but that's essentially what it's doing. All right, so when we take the two data sets, that first data set would have a mean of 30.6186. That data set that we just looked at has a standard deviation of 2.5495. The first one has a larger standard deviation, so it has a larger spread. And I'll show you in just a minute how to get those values in SPSS. Let's look briefly at the variance. The variance is just the standard deviation squared. The variance is, statisticians use it because of the normal distribution, but for us it's not all that useful. We like the standard deviation because it's in the same units as the data. So if your data is in seconds, then so is the standard deviation. But the variance would be in seconds squared. So that's a little harder to it's a little harder to interpret. Now, you can look in your book or on the internet or something and see the population standard deviation, and that has a slightly different formula. And I'll tell you what it is. The only difference is that you're not subtracting 1 in the denominator here. And of course, this would be mu up here. It's slightly different, but we're not going to calculate it. Keep in mind that we're looking at samples and we're using them to estimate populations. So all the data we're going to have is going to be the sample standard deviation. All right, so let me show you quickly how to get this in SPSS. So I have pulled up the virtual desktop, and I'm going to open SPSS. And this also is going to show you how to type in data from scratch. And I'm going to pause this because it's going to take a sec for SPSS to open. All right, so I've got SPSS up. This is an empty file. And if I want to type in data, you can put in a variable name if you want to, or you can just go to data view and start typing. So I'm just going to go to data view and start typing my data set. So 74, 70, 69, and then 67 and 70. And if we want to get the standard deviation and the variance and the range, we've actually done this before. We're just going to use the same explore function we used before. So that's under analyze, compare means, analyze descriptive statistics, explore. And we're going to take our variable and move it over to dependent list. And we're still only interested in statistics. And we'll click OK. And so this tells us that our mean is 70, that our standard deviation is 2.5495. This tells us our variance is 6.5, which is what we found, and our range is 7. All right, so that's how to do that in SPSS. I want to show you one thing that is nice about my stat lab. And when you're doing these, you can you can take this shortcut. So here's a problem in MyStatLab that you might see on your MyStatLab homework. Now, you don't have to do these by hand unless it specifically says to. And you don't even have to enter this data anywhere. Because if you see the two boxes here, you can click on that box. And if you click Open in StatCrunch, it pulls up this calculator that will find it for you. And so if you want the shortcut, here it is. Stat, Summary Stats, and pick the columns. We're just going to pick that column we used. And we want the standard deviation. And if we hit compute, that's going to give us the standard deviation of this data set. All right, and that's available on most of the MyStatLab problems. All right, so that's it for this lesson. And if you have any questions, always let me know.